How can we visualize CNN decisions for image classification? Imagine trying to understand how a computer decides what's in a picture. It's like peeking inside its mind to see what parts of the image it's paying attention to. That's what visualizing decisions in convolutional neural networks is all about. These networks are the backbone of many image classification tasks. They learn to spot patterns like edges, textures, and shapes in images. Once trained, they can tell if a picture contains a cat, a car, or a bird. But understanding how they make these choices is just as important as the choices themselves. It helps us trust the system and improve it over time. One way to do this is with saliency maps. Think of a saliency map as a grayscale overlay on the image. It highlights the pixels that had the biggest impact on the network's decision. Bright areas mean those parts influence the outcome the most. For example, if the network says an image is a dog, the saliency map might show bright spots around the dog's face or body. This helps us see if the model is focusing on the right features or just random patterns. Another popular method is called gradient-weighted class activation mapping, or Grad-CAM. This technique creates a heat map that's layered on the original image. The heat map shows which regions the model thought were most important. Bright colors like red or yellow indicate high importance. So, if the network classifies an image as a bird, Grad-CAM might highlight the bird's beak or wings in bright colors. This makes it clear which parts of the image influence the decision. Guided Grad-CAM takes it a step further. It combines the heat map with detailed pixel information. This way, you can see not just the general areas but also the specific pixels that mattered most. It's like zooming in on the decision process to see tiny details that help the model decide. All these visualization methods are called post hoc. That means they are applied after the model has learned to classify images. They don't change how the model works but give us a window into its reasoning. This is especially useful for debugging. If the model is focusing on irrelevant parts, we can fix that. It also helps in sensitive fields like medicine or autonomous driving. For example, in medical imaging, visualizations can show which parts of an X-ray the model used to diagnose a condition. In self-driving cars, they reveal which parts of a scene the system is paying attention to when detecting pedestrians or obstacles. From an ethical point of view, these tools support transparency. They help us see if the model is making fair and reliable decisions. If the model is relying on biased or incorrect features, visualization can reveal that. This way, developers and users can question and improve the system. As AI tools like ChatGPT, DALL-E, and Midjourney become more common, understanding how they make decisions becomes even more important. It helps ensure these systems are used responsibly and ethically. In short, visualizing CNN decisions for image classification involves techniques like saliency maps, Grad-CAM, and Guided Grad-CAM. These methods highlight the parts of an image that most influence the model's prediction. They make the decision process clearer and more understandable. This not only helps improve the models but also builds trust and accountability in AI systems.